Okay. Can you all hear me well now? I assume so. All right, so the Berryessa region is just west of Davis. This is Davis over here, Vacaville, Fairfield down below, and Napa. The blue circle is roughly the Berryessa region. It's an undiscovered landscape. Some of you know it as the shortcut to Napa from Davis. Some of you know it as just the lake where you go have recreation. The Audubon folks probably know it because it's part of the Christmas bird count area. This is the Christmas bird count area. This mostly on the east side of the lake. I want to encourage you to kind of go out and explore other parts of the lake. So my original presentation got altered recently, as you probably all well know. This is the slide I took back in February. And I wanted to highlight this is not a good time to go out and visit the area. Just wait until the spring because this is what it looks like as of 2 weeks ago, the same location. The cloud in the background is smoke from the August fire that was burning and pushing smoke from the north. This is from the LNU complex fire that as of September 7th burned over 375,000 acres. As you can see from this picture, the blue circle, the area of the book, has been pretty much covered by this fire. It's been rather heavily hit. This is in the upper left corner is the Rag Canyon as you take Highway 128 west of Monticello Dam. It's a pretty severely burned area now. The lower right shows some of the houses. A lot of the houses were lost in the Spanish Flat area. It's pretty heart-wrenching to see the devastation that happened out there. Just places that are burned right down to the foundation. But a point here is that life still finds a way here. This is a deer along Capel Creek that I took on that same day I went out to photograph. The riparian areas are actually surprisingly better than I expected because they had so much moisture in the leaves. So wait until next spring before you go out there to explore this area. The utility crews are still out there. They were replacing hundreds of poles and miles of cable, trying to reestablish power and telecommunications. So just don't let them recover, basically. So the big question is this all bad? Are fires bad? Well, sort of yes and no. It's clearly tragic for people who have lost their homes and their towns. But California is a fire-adapted ecosystem, and it has been for thousands of years. Many of the plants are well adapted to fire. And although it can take a while for ravaged towns to recover, plants can recover fairly quickly. The top row are pictures from the Cahill Reserve, just up near the mouth of Buda Creek Canyon after the 2015 Rag Fire on the left, and 9 months later on the right. Grasses have come back. In the foreground, actually, there's quite a number of native grasses, though there's a lot of introduced grasses in the background. On the lower row, you'll see pictures that were taken at the Stebbins Cold Canyon Reserve right after that fire, and then again 9 months later. So the vegetation comes back pretty quickly. And given a wet year after a fire, the wildflowers can be pretty beautiful. These are pictures that were taken after the 2014 Monticello fire. The problem is that even though fires are natural, the fire regime has been dramatically changed. This particular place, in Buda Creek Canyon, burned 3 more times after I took these pictures. Here's a picture of that LNU complex fire. But if you look at the number of fires that burned just since 1980 in this region, there are a large number of very extensive fires. Some places just burned multiple times, 3 or 4 times. We also have seen that over time, just from northwestern California, then the fire regime has changed dramatically. In the early 1930s, 1940s, there were not a lot of records of fires, but by the 1950s, people were moving into rural areas and there were more ignitions and more fires. During the 60s and 70s, there was a lot of fire suppression, so the number of fires and acres burned reduced. But in the last 20 years, we have had a lot more large fires. Those areas that are in the red are the ones that are over 100,000 acres in size. So we've significantly altered fire regimes through fire suppression. The climate's getting drier and warmer, and there's more people coming into this area, which creates more ignitions for fires. Okay, so now I got that out of the way, I wanted to get onto the main part of what I was going to say. Let's start looking deeper into the landscape of Berryessa. And let's look at it from a geological point of view, an ecological and historical point of view. From a geological point of view, this is a picture of Monticello Dam and Lake Berryessa. In the far background, you can see out here is Cedar Ruffs, and there's a piece of the lake out here. And a lot of people are very familiar with those really steep bedding at the dam. So you've probably noticed that from a geological point of view. But how did those form? There's also, if you look deeper, there are other things about the geology of the area, and it attracts geologists from all around the world. There is a strange mix of rocks that were really formed in a geological collision zone. And we have slabs of deep ocean floor that have been thrust up onto the continent. These are, I'll tell you more about ribbon cherts and pillow basalts later as I get into it, but they are basically were formed in mid-ocean. There's also large chunks of volcanic rocks that were formed in a mixing trench of a subduction trench of a lot of rocks being chewed up. I'll tell you some more about that. And there's also rocks like blue schist and ecology that have been formed 12 to 18 miles below the surface by extreme pressure. And then they're now been forced up to the surface here so you can see them. Beyond that, there are serpentine mud volcanoes, and there's these vast deltas of submarine fans. It's a lot of interesting geology in this area. From an ecological point of view, when you drive through this area, you are pretty obvious. You see that there's a transition from the east side, where you have relatively dry blue oak grasslands. This is Bobcat Ranch. And as you go west, you get into redwoods, and you get places where there's lace lichens that are dependent on fogs. So it's a clear coastal transition that you see. A number of you might already be aware of the number of rare plants on the serpentine soils in this area, but you might not know how important, how nationally significant this area is in terms of rare species. This is a map that the Nature Conservancy put together looking at the density of rare species across the country. And it shows that the area over here in the North Bay area, Berryessa basically, is a real hotspot for lots of rare species, plants and animals. From a historical point of view, as you go through, you may be aware of the flooding of Berryessa Valley. In the 1950s, this was a fairly rich agricultural area, a lot of wheat being produced out in this area. This is a picture taken in 1950. The dam flooded this area in 1957. But you might not know about, for example, the people who lived here for thousands of years, the Patwin and the Lake Miwok people. You may not know about John Wolfskill, who settled by Winters, one of the earliest settlers, and he was a pioneer in establishing fruit trees. Joseph Childs on the right, yeah, it's the same Childs that we have Childs Road in Davis. He actually ran a flour mill up in Childs Valley before he came to Davis. There's some other interesting historical stories about the Berryessa family. that the Berryessas were a large group of Basque settlers, a large clan of, that settled in the Bay Area and had extensive land holdings, including the Berryessa region. And one of my favorite historical stories is the use of Putah Creek Canyon during the Mexican-American War as a sneaky espionage route. So those are some of the historical stories that this book explores. There's other important stories in terms of conservation and education. There's been a lot of work done in this area to protect land and to educate others. This is a map of the public and conservation lands in the Berryessa region. And you can see there's Cedar Roughs Wilderness, which is BLM land over on the west side of the lake. BLM owns quite a bit, or manages quite a bit of land on the east side of the lake. This is Bobcat Ranch down here. There's also quite a bit of work that's been done on easements. These are a lot of easements that are done by the Land Trust of Napa County, which is still private land, so it's not accessible for the public, but it does keep the land in a protected status. Oops. One of the elements, the more recent elements for conservation is the Berryessa Snow Mountain National Monument. In this map here, where Berryessa is down at the southern end of it, and the area outlined in red is the national monument that extends all the way past Clear Lake up into the Mendocino National Forest to Snow Mountain Wilderness. The national monument only addresses federal lands, but there's a lot of opportunity for collaboration with other land agencies. So the book is one of the parts of the book is to actually celebrate and to get people to understand a little bit more about this national monument. There have been a lot of conservation and education groups that have worked on this area for a long time. The Putah Cache Bioregion project was one of the first ones from the UC Davis that got people out and exploring the Berryessa region. But there's a whole bunch of other partnerships and organizations that have worked in this area. Just wanted to acknowledge their role. So there's a lot of stories to tell about this region, and we wanted to publish a book to tell a number of these stories. Our goal was to encourage people to actively explore the region, to learn more about it, to increase their support for conservation of the region, and to increase their support for the National Monument. We were particularly fascinated by the geological wonders, because that was our background, and how that landscape formed. We dedicated our book to Eldridge Moores, who's our primary author. He unfortunately died tragically during the project. Eldridge was a pioneer in plate tectonics in the early 1970s. He's a former president of the Geological Society of America. I also hear he played a pretty mean cello for the UC Davis Symphony Orchestra. Eldridge led public geology tours for 25 years in this region, along with his wife, Judy Moores. And we wanted to see if we could capture that knowledge in a book form that would last well beyond his time. The book is available at backcountrypress.com. You can also, there are a few copies down at Avid Reader in downtown Davis. Beyond Eldridge, the other authors of the book were Judy, Eldridge's wife, who brought the humanist side to Eldridge's public scientific tours. She co-founded the Davis Science Center, which is now called Explore It. Peter Schiffman, in the left picture, second from the left, is an emeritus UC Davis geologist, and he was Eldridge's colleague for 35 years. In the picture, we have Eldridge here as a picture of myself. Bob Schneider took the picture, so he's not in this picture, but here's a picture of Bob on the right. And Bob co-founded both the California Wilderness Coalition and Tuolumne, and he led the effort to designate the Berryessa Snow Mountain National Monument in 2015. So here's a map of our book's tour routes. we break the book is designed as a road guide. It does have mileposts all throughout it. And it breaks the region into segments there's a segment between Winters and Rag Canyon over here. This is Turtle Rock. We have descriptions along the west side of Lake Berryessa, up to Pope Creek, over to Pope Valley, and up to Etna Springs. And then we also have sections that come all the way down to Lake Hennessy. Okay, so we cover a lot of topics in our book, but our main focus was really the geology. And we wanted to describe to people how this landscape formed. So what I'm going to try to do is simplify this geological history for you. And what I want to do is be able to help you understand how the geological features you see form, but also to get you to pay attention to the ones that you may not have noticed yet. In a very quick summary, the idea here of plate tectonics is that the crust of the earth is broken up into plates that formed in these, let's see here. Oops, sorry. Let's see if I can go back. Yeah, I'm gonna try and get my mouse here. My mouse is not working. But they form at ridges in the middle of the plates with this magma that comes up from the interior of the earth. Then they spread outwards towards their edges where they collide into other plates, and then they are subducted, or they're a collision of mountains. This is basically the quick sketch of plate tectonics. What's interesting about the Berryessa region, you'll see in this the area in red circle is where California is. And the red arrows are showing that the plates are actually sliding past each other. The interesting thing about this area is that it has three types of plate boundaries. We have elements of an old divergent plate boundary. Actually, there's the south and north of it, there's still an existing plate boundary. The idea here is that the magma comes up from below and it reaches the surface and spreads out away from that ridge. Out where two plates collide, one of the plates drops down and is subducted underneath an overriding plate, and it forms a trench where these plates are colliding. And a third type of plate is where plate boundary is where plates are actually sliding past each other. One goes one direction, the other goes the other. They're not going underneath each other, just sliding along the side. So we actually have all three plate boundaries in this area. So how did all this, how did all the different kind of rocks in the Berryessa region form? Let me take you back a little bit. 170 million years ago, and this is when the dinosaurs were still roaming the earth. The bar at the very top gives you a geological timescale from around 170 million years down to the present here. And in this particular slide, we're looking at the area of 170 to 50 million years ago. And this is the North American plate that's moving to the west. And these are plates out in the Pacific that are beginning to subduct underneath North America. But surprisingly, a chunk of the ocean crust, this green area, breaks off and is forced up on top of the continent. So we have a piece of the continent here with its ocean crust that's up on top of it. We call that an ophiolite. You may hear me use that word a few times. I'll try not to use too much jargon here. Let's see here. Let me make sure I'm still on. Okay. If you scoot forward about 100, I'm sorry, I have a little bit of a problem with my notes here that just shifted. There we go. Okay, sorry about that. If you move forward to the period between 150 and 70 million years ago, the subduction is not going smoothly. There's a real pileup of material at the trench. This is kind of like trying to push a towel underneath a closed door. it just doesn't go smoothly, right? And what's happening is there's this pile up accretion of material that's from the upper plate and the lower plate, and it's creates this uplift near the plate boundary, the trench. There's this contraction of the overriding plate because it's just being squeezed from both sides. And then there's the plate that's down, being subducted, dropping into the trench, gets down deep enough that it begins to melt. And that melted magma starts to rise to the surface and put granite up where the Sierra is now and erupting to the surface into volcanoes. These areas erode down and they deposit in the intervening valley between these two uplifts. So that's the quick little sketch of what was happening for about 80 million years. Let's look in a little bit closer at this area, because this is where we're talking about with the Berryessa area. And this area is a tectonic rock factory. And this I like this particular slide because it really explains why there are so many different kinds of rocks there in this area. The bright orange area here is the plate that's being subducted down underneath the overriding plate. You'll see this orange area on the upper right. This is that crust, ocean crust that was broke off and has been lifted onto the North American plate. As this plate here is, as this plate is being subducted, it's made out of basalt, it's made out of gabbro, a variety of, and at the down deeper enough, it gets into peridotite that's been hydrated to serpentine. So this is where your serpentine is coming from. On top of these plates, there are these undersea volcanoes that form seamounts, and those get carried along down here. Here's one that's being squeezed down underneath the North American plate. This is where the pileup is happening. This is material from the upper crust being dropped, upper plate being dropped in. There's pieces being dragged up from the lower plate. A lot of tectonic mixing in this area. And this is the Franciscan Formation or Franciscan Complex. As this is being squeezed down here, there's this pressure that creates these normal faults that are pushing the land up. So the crust is starting to break up. And as it's squeezed down deeper, it gets into a jumbled mess. It's just getting really crunched up. As it goes even deeper, you start having blue schist and ecology being formed at really deep pressures. And there's also the pressure down there is squeezing, is dehydrating the serpentine, and that water rises back up until it finds the weak zones like the faults, and it rises up along those faults, the purple lines there, and erupts on the surface as a slurry, a buoyant slurry that's bringing with it pieces of volcanic rock from the descending plate, that's bringing up blue schist, it's bringing up ocean sediments, and it's bringing up serpentine in just a huge mix of these volcanoes. And then it's with multiple eruptions. It's not a hot volcano. It's a kind of a colder slurry, but it mixes with the sediments that are forming out there. So that you now have sandstone and shales mixed in. This whole area, these mud volcanoes keep erupting, but they're on a conveyor belt that is moving to the left until it reaches that trench and it gets mixed again. So it's like this big conveyor belt crunching rocks and creating rocks. And that explains why we have so many different types of rocks in this area. Let me explain a little bit more about these sediments. I call it the GVG is the Great Valley Group. Here's a 3D conceptual view of it's basically Central California. The blue line is a sea level line. Most is happening below the sea level. This is the ancestral Sierra Nevada and the Klamath Mountains. This is that descending plate in blue with the pileup with the Franciscan Formation. And it's creating this basin in between the uplifted Sierra Nevada and the uplifted area of the Franciscan. And you have these these alluvial debris from the streams being washed down into the basin. Let me show you an example of that looks like a little more closer. Imagine that here are streams, rivers coming down to the ocean in blue. And it's depositing a lot of sand and silts and mud, and that piles up on the continental shelf. And it keeps piling up until it either is overloaded or there's an earthquake. And then that debris flows down these canyons as a slurry. It's like sand and water, sand mixed with water that flows all the way down to the basin plain and spreads out just like a sort of an alluvial fan you'd see in Death Valley or someplace. The sands are the coarser layers, and they're deposited close to the shelf, and the muds get sort of distributed by the water out further. So you see a lot more mud out in this farther part of the fan and a lot more sand in the beginning, in the upper part. That's important when I show you a picture of the sandstones around Monticello Dam. This is an image of that Great Valley group. These ridges all the way across here are pretty much all sandstone or shale. The shale is more easily eroded and forms the valleys, and the sandstone forms the ridges. So you have this alternating pattern of sandstone and shale and sandstone. But this is all these ridges you see on the front range of the Coast Range here are the submarine fans that have been tilted up. So I told you how they were deposited. Now let's move a little bit further forward. We still have this compression of North America and the Pacific Plate. And here's another slide of the descending plate down here on the lower part. And this is the upper part. You see this Great Valley ophiolite. That's that ocean crust that's been broken off and put up onto North America. But as North America continues to get squeezed, it starts faulting out and creating these thrust faults. So we have parts of it that gets pushed up on top of the other part down below along the Great Valley fault system. And then there's continued squeeze and starts folding the upper layers here. And this purple that goes up into the air and kind of comes down, this is a piece of that ophiolite. It's dotted because those are areas that have been eroded since it was formed. But you can tell by how the beds are tilted what's happening. Let's look at it a little more closely at that area. This is the area from Monticello Dam over here. There's Lake Berryessa, Lake Hennessy, Napa's over here to the left. The colors here are a geological map. It shows different kinds of rocks. The greens are the Great Valley group. The purple is the serpentine. The blue is the Franciscan. And if you take a line across the whole region and tilt the landscape up on the side, what's underneath there, this is the cross-section view on the bottom part of the slide that shows you what's going on. And over by Monticello Dam, the beds are very steeply dipping. But as you move across Lake Berryessa, they get less steep. And over here on the west side of Lake Berryessa, you find the Trout Creek anticline. These dashed lines are indicating what probably was there before it was eroded. The solid lines are the landscape right now. So it's been a huge arch of the landscape over the Trout Creek anticline. If you continue to go west into the Pope Valley, Childs Valley, there's a sort of depression basin of sediments. And then off to the west, another uplifted arch or an anticline over Childs Canyon. So this whole landscape has been folded in huge ways. These are miles across. Okay, so the next, I want to also tell you a little bit about the San Andreas Fault. And the San Andreas, of course, is over there by Point Reyes, but there are multiple faults that are similar to it into the Berryessa region. These are faults that are moving sliding past each other rather than going up or down. And the San Andreas is a transform fault. And let me tell you what a transform fault is. At the spreading centers, or in the middle of the ocean, you have this magma that's coming up, and the crust basically spreads out from one side and the other, but they're offset by these fractures. And the upper left picture shows you some of the fractures in the mid-Atlantic ridge, just to give you an idea that it's not a straight line straight across through the ocean. And where these things are offset, here's an axis of a mid-ocean ridge. You can see that on the left side of it, it's going to the left. But if you move back across the transform fault, you see the ground is actually going to the right. So these areas are sliding past each other, and that's what the San Andreas fault is. Let me show you a little bit more of the history of it, and then we'll be wrapping up pretty soon the geology part here. Let's see, let me close something here. This is starting from around 30 million years ago, is when the Pacific plate moved in close enough and split the Farallon plate by colliding with North America. This is one of the spreading centers, and this is one of those offset transform faults. This is the view around 30 million years ago. This continues to move into the North American plate, so that by 20 million years ago, you actually have the collision, and the subduction that was happening stops where that San Andreas fault is now. And instead of the plates being subducted under the overriding one, they're starting to slide past each other. And this transform fault is the San Andreas, and over time, it keeps extending such that it covers now the area from Mendocino County down to south of, Baja California. So that's the San Andreas fault, and this sliding the sliding that's happening is the kind of faults that we have actually in the Berryessa now, the more recent faults. Okay, one last bit of geology I wanted to tell you about are the flood basalts, and I find this rather pretty fun. Around 16 to 14 million years ago, there were these extensive flood basalts up in Oregon and Washington, but there was also one in California. And up at the northern end of the Sierra, up by Susanville, is Thompson Peak, has this unique basalt that has been mapped in these red outcrops all the way down off the Sierra, down to North Table Mountain by Oroville. Some of you go up there to see flowers, I'm sure. And across the valley, by the Orland Buttes. And in the middle of the valley where they've been drilling wells, they keep finding this basalt really deep. So we know it was someplace in this area. And if you come all the way down to Winters, you'll see on Bobcat Ranch and right there in the along the highway are volcanic boulders. Those are the same basalt that came from Thompson Peak up by Susanville. You can also see them at Putnam Peak in Pleasant Valley. And if you go down to Vacaville, just northeast of Vacaville, you'll find them as well. This is lava that has flowed 150 miles from Thompson Peak. The basalt erupted, it erupted about 25 times and eventually covered about 25% of the Sacramento Valley at the time. And now it's just been covered up with a lot of sediment since then, but it is still exposed in various locations. Okay, so I gave you a little bit about the story, the geology, how it landscape formed. Let's just go for a little virtual field tour. And what we're going to do is we're going to go from Winters area up through Putty Creek Canyon, Monticello Dam, out along towards Muscovite Corner, Turtle Rock, up the west side of Lake Berryessa, out over to Pope Valley, and then briefly at Etna Springs, and then come back down by Lake Hennessy, a place called Sage Canyon. And this one is really I want to just give you some highlights of it just to inspire you to get out there and explore this area. So the first one, the geologists call this area at the mouth of Putah Creek Canyon, just west of Winter's Black Rocks. And I think the birders might have a different name for it. So I don't have the chat on right now, but I'm sure you guys will tell me if there's a different name for it. But these are the Lovejoy basalt boulders that was from lava that started 150 miles away and flowed down this area. There's a lot of stories that have been told at the mouth of Putah Creek Canyon. And just look in the road log of the book and you'll see a bunch of stories there. As you move up to Monticello Dam, here's a picture of the Veneto sandstone right by the dam. And you can see those beds are sharply tilted. And see that really thick layer that's just over on the left side. That's all sandstone. And then you have this siltstone just right behind me in this picture. And it has alternating thin layers of sandstone and thick mud. This is all part of those submarine fans that flow down into the 6,000 feet of water and were uplifted here. Going up the road a little further, you get into Rag Canyon. And the fun part about this is you start entering the area where there's enough winter fog that you can support lace lichen. And this is the state's official lichen. And I love this one. You've probably seen this stuff just hanging from the trees, but you really should walk up and look at it really closely. It is lacy. It is beautiful. And it's not Spanish moss, but it's a lichen, and it's not parasitic. It just hangs on those trees. And if you're looking at the lichen a little closer, spend some more time looking at the moss and other kinds of lichens. There are beard lichens and oak moss lichens and other kinds of fun stuff on these trees in this area because there's enough fog to support it. Up by Muscovite Corners, this is where Highway 121 and 128 junction. There's a huge rock called Rainy Rock. This is one of those large volcanic blocks that was scraped off the ocean floor and dropped into this whole mixing bowl. Going up towards Lake Berryessa through Capel Valley, there's this is where you first really begin to find serpentine. This is the closest serpentine you can find to Davis. But what's interesting about this is that the serpentine, which is really from an oceanic source, here is on top of a continental deposit, the Great Valley Group. Through faulting, or it's basically through faulting. It's been squeezed up on top of it. It's like a reverse pattern. Out along the west shore of Berryessa, well, you know, if you're going to count a silver lining for fires, it does make the rocks easier to see. So these are some volcanic blocks that I just noticed much more clearly after the fire. Same kind of thing as that Rainy Rock. As you go north, up along the west side of Berryessa, you get to Pope Creek Canyon and drive up that route. You'll see pillow basalts. And these are really cool. Basically, these are formed where hot lava erupts into deep ocean water. And when it comes out there, it cools so quickly, it starts to create a layer of rock. But there's still more magma, hot fluid stuff coming from behind, pushing it out. So it breaks up and then it makes a larger crust. And it keeps pushing out and freezing until it forms like a frozen pillow shape. So that's what you'll find out there in Pope Creek Canyon. And you get up into Pope Valley. This is a view from a really neat trail, the Pope Valley to Putah Creek trail that unfortunately was just burned pretty intensely in this last fire. But a lot of serpentine on that trail. On the far side of the valley, you'll see this ridge. It's a fairly flat ridge and it's a lot darker colored. This is where you get into a lot more coniferous forest. There are redwoods up on that ridge. And this ridge is formed by some fairly recent volcanics, less than 8 million years old. On the right, you can actually see a few of those little cones where some of the volcanic basalt flowed out of. And then from Pope Valley, you can head north up to Etna Springs. And Etna Springs is a resort and a spa from the 1870s. And actually, it's just one of several soda springs in the area. Some of these things are almost inaccessible because of the lake right now, but they were popular among visitors in the late 1800s who would come over to seek cures for various ailments. Etna Springs was also one of the first golf courses west of the Mississippi in 1891. And in the 1970s, it was used by the Moonies, the Reverend Moon's Unification Church, if you remember those stories. It closed in 2009, and there have been several unsuccessful attempts to open it, so it's still closed, unfortunately. Coming back south out of Pope Valley, I told you we're going to go down into Childs Canyon, and just at the mouth of Childs Canyon, you can actually find a historical marker for Childs' old flour mill. That's where he did the milling of the wheat that he grew up in Childs Valley. As you go down the canyon, heading towards Lake Hennessy, it's a tricky spot. There's not many places to pull over, but you'll find these ribbon cherts. You can see the thin layers of rock in here. Chert, let's see if I can be official here. It's like made of a gazillion skeletons. These are the skeletons of siliceous animals like glass sponges, diatoms, radiolarians, all plankton that's living out in the ocean and dying by the gazillions and settling. Their skeletons just fall to the ocean floor, and it keeps piling up and eventually turns into rock, which is basically a type of quartz. And then the last quick little spot on our virtual tour is in Sage Canyon. And this is one of our favorite spots because this is where we can find blue schist and eclogites exposed on the surface. As I mentioned, those are the rocks that were formed under great pressures 12 to 18 miles below the surface. And here we're looking at them on the surface. So, and just a quick little wrap up. I hope you enjoyed that virtual tour. I hope you learned a bit more about the Berryessa region, and particularly the geology of this really fascinating landscape. Once the land recovers, I encourage you to go out and explore on your own. You can pick up our book at backcountrypress.com or the copies down at Avid Reader. The book is a mile-by-mile field guide to a lot of these spots I showed, plus more. It's full of photographs, has simple graphics. For those of you that like geology, there's detailed geology maps in there. It's really just chock full of information. And I just encourage you to go out and pick up a copy. We hope that, the book really helps you learn more about the area, and that it helps you support land conservation in the area, and particularly help support the Berryessa Snow Mountain National Monument. So thanks for listening, and I appreciate your time.
Hello. Oh, good. I'm back on. Thank you, Mark. That was pretty good. I enjoyed it. I enjoyed all the subduction and all that sort of stuff. Really cool. I want to thank you for your presentation. And I'd like to ask anyone now, any questions for Mark? Allison wants to know who did the watercolor on the front cover.
Oh, that was Obi Kaufman, who is speaking for the Native Plant Society tomorrow afternoon. Obi has done he's released a recent book about, oh gosh, Bob can tell me what the book is. But yeah, he did our work.
Okay.
I have one, Ken.
Okay.
One person was wondering if you could describe a couple of the rare species of plants and other stuff that you were mentioning at the beginning, how it's a hotspot for rare species, and if you could give some examples.
No, I don't. I don't have those in my head right now. There's a lot of different rare species out there, and if you just look up serpentine in Napa County, you'll find out all kinds of information. The Native Plant Society local chapters lead walks out there every spring to go look at the serpentine plants.
All right,
Okay.
next up is, do you have any thoughts about how the new fire regime, aka climate change, is changing the vegetation? And for example, will the oaks come back on the north side of Pitter Creek Canyon with the fires happening so often?
So this is going to be a real challenge here. As I mentioned, the plants are fairly fire adapted, but they need time to recover. And so even chamise, but a number of these plants have root balls that are below the surface. So when a fire sweeps over and burns off the upper growth, it just comes back from the root growth. But if you keep burning that so frequently, you're going to exhaust all the potential for that plant. And it's likely that you can have these shrublands and blue and oak woodlands turn into more grasslands because they can just tolerate that kind of fire. So there is potential for real conversion of the habitat as if the fires continue with this kind of frequency.
And then how are the animals affected by the fires, and then including like the birds? What do you think about that?
I don't know, but there is research being done on Bobcat Ranch, and I cannot remember his name right now. And Audubon is doing bird phenology on Bobcat Ranch, but there's somebody else looking at sort of the fire ecology related to the birds.
I think Frank Fogarty
There you go.
had done it a couple of years ago, and I hadn't heard. If maybe Steve Hampton may know if he's come down from Humboldt or planning to come down from Humboldt after things clear up with these fires.
But the Audubon phenology work being done out on Bobcat Ranch will be a really good monitoring program, because the place is going to burn again. It's just it's unfortunate, but there are so many people going through Poudre Creek Canyon. There have been the place has burned so many times, primarily because people are not careful out there.
In fact, we've gotten clearance to restart the phenology surveys. I think they're either this week or next week. Be the first one in a while. Someone wants to know, does mud have a different meaning to a geologist than for others?
Well, I suppose so. Mud in its very simplest form is sediment that is so fine that you don't even feel the grit in when you run it between your fingers there. And it's not quite clay. Clay actually will form balls if you roll it between your finger, but mud is just really very fine sediment. It's finer than silt, and silt is finer than sand. I'm not sure if that answers it. Hopefully it does.
Let's see if they did a follow-up note. Okay, here's one. Is there an explanation to why this region retains evidence of all three types of plate boundaries? And is this unusual?
I don't know from a worldwide point of view, but it does attract a lot of people. We do have evidence of we have materials that are brought here, like the pillow basalts that are representing the spreading centers. And then we have materials from the subduction zone, which is like the ecology and those deeply pressurized rocks. And then we have these faulting more recently of basically a transform fault. You know, when we talk about the San Andreas fault, it's not just simply one fault, it's really a fault zone. And this is the area where North America slides past the Pacific plate, but it doesn't all happen there. About 75% of the movement between the two continents is in the San Andreas fault zone. Another 25% of it is on the east side of the Sierra, and then another 3% are out there in the Great Basin. So it spreads out over a broad area. So we do have that transform fault feature in this area as well. The best, it's I would need to spend a lot more time explaining that. I think the book will probably give you a bit more about that, and I can gladly take questions later from people offline.
Some people would like to know if you're going to be running tours in the area in the future.
I would love to. That was actually one of my initial drivers for work on this book with everybody, is that I wanted to kind of continue those tours that Eldridge and Judy led. My wife, Carrie Shaw, was at the time executive director of Putah Creek Council. She wanted me to go out and lead more tours. So this book provides a really great basis for me to do that. So I would love to. I just have to get over all this virus stuff.
Okay. Zane, do you see any others?
Yeah, there was one other one. Hold on. Are there examples of potentially active faults mapped in the Berryessa region, like ones that could generate sizable earthquakes, or is really most of the plate motion being accommodated by the East Bay and the West Faults?
No, on the west side of Berryessa, I'm not sure how active the Berryessa fault is, but it continues up along the west side of the lake, and they've been doing quite a bit of research on it recently. I don't have a good answer on how recently things have moved, but they're fairly recent faults.
And then Ken, this one's kind of more for you, but is there going to be a recording available later, and where might that be?
Yeah, as Ann mentioned at the beginning, this is our first take at this. So I am recording it, and what our plan is to have the presentations be available on our website, or a link on our website. We'll create a YouTube channel, or however that we can get that out there. But yes, our goal is to have it so that folks can take a look at it again.
Do you see Sammy's question?
No. Oh. Okay, it's not complete question. Oh. Mark, go
I
ahead.
can actually see it. Yeah, it's Sutter Butte.
Okay.
Yeah. Sutter Buttes is a rather different story because it's a volcanic chain that's out in the middle of the Sacramento Valley, and the valley itself is relatively flat. This is actually probably the southernmost expression of the Cascade volcanoes that are Lassen and Shasta are all part of those volcanoes. So it's a somewhat more recent, different story than the Berryessa area.
Okay. Do you see the one, Mark, about a memorial for Dr. Morse?
Yeah, I don't know what kind of memorial might be possible for him out there, but I think collaboratively we can put our ideas together, and Judy would be a great supporter of it, I'm sure. So we could probably work something out of it.
Okay.
Mark, another one for you is someone's curious about the geology of Mount Vaca and if that is related.
Mount Vaca would be part of the Great Valley group. There's submarine fans that I talked about, and it's just a if I remember where it is well enough, it is just simply part of one of the sandstone uplifts, unless there's something else. I can't quite visualize it with a geology map in my head, but I know that it's probably the same as that Great Valley group.
Okay. I think we got to all the questions. Okay, the recording, yeah. Steve Hampton is shamelessly promoting the Christmas bird count, so which has a 49-year data set on birds in the area. The CBCs provide important data for documenting bird population shifts with climate change as well as normal successional changes after a fire. And I don't know if everybody knows this, but you can go to the National Audubon site and explore the Christmas bird count data from all the count areas in the country and probably internationally. I don't know how you would use it, but you can certainly see what's going on in certain areas.
Steve has a lot of experience with that bird count data, and I think it'd be great if somebody from Audubon would be interested in actually taking that and comparing it with some of the fire history maps, and to see if there is any difference in terms of bird counts related to the fires.
Okay. So Mark, someone wants to know if there going to be if they're going to be tours offered in the future, how will they find out? How will folks find out about them?
Chances are I will be working through local groups like Yolo Audubon, Putah Creek Council, Tuolumne. So I would use those groups to help me do the logistics. The tours can be done with multiple cars, but it's actually easier to do with a couple of vans, frankly, so you don't have problems. So I would need somebody to help me do that. And so local organizations would be my ticket for that.
Okay. Okay, I think we've gotten to all the questions, I'm pretty sure. And I guess we can go ahead and wrap this up. And once again, I want to thank you, Mark, for this wonderful presentation. And I want to thank our guests for spending your evening with us here. And I hope you have taken away a set of knowledge that you'll have an opportunity as things loosen up in the future to put to use by taking that driving tour. So fantastic. So thank you all. Thank you, Mark, especially. Really appreciate it.
Thanks,
Okay.
Ken.
All right. So thank you all. And I guess we can conclude our meeting.
Okay.